Good morning to all. First of all, thank you so much for giving me this opportunity. Myself, Satar J, School of Electrical Engineering, Bour Institute of Technology, Bour. My presentation topic: Performance Analysis of Wind Power Forecasting via System Advisor Model Software. Now I am presenting. Now I am going to present the abstract. Renewable energies obtained from the natural sources. The most important of renewable energy sources are solar, wind, geothermal, biomass, tidal. These are the most important of renewable energy sources. In my work, I have choosing wind energy. So wind energy is one of the most significant renewable energy sources. So the renewable energy source of wind power generation is rapidly increased in recent year. The world total wind power capacity was 840.9 gigawatts up to 2022, and the India total wind power capacity was 41.93 gigawatts up to 2022. I have chosen three different land in USA in my research work. The three different lands for flat land, Kenya land, and offshore land. The three different lands wind power performance and analysis using system advisor model software. Next, introduction. So electrical energy is a more important role in day-to-day life. So electrical energy is very demand for economic activity. So the main reason for electrical demand, conventional energy is reducing, increasing the population and increasing the industrial sector. These are the main reason for the electrical energy demand. So to find the alternating energy source for non-conventional energy sources, the most popular non-conventional energy sources are solar energy and wind energy. This is the most popular non-conventional energy sources. So in this work, focusing on the wind power forecasting to identify the wind power potential at various locations. The system advisor model software developing the wind system model and prediction of wind power. So the system advisor model server development software is desktop application. This is the open source software. Next, system advisor model software. So the system advisor model software is originally is called as solar advisor model software. This software was developed at National Renewable Energy Laboratory with Sandia National Laboratories in 2005. So in 2010, the system advisor model the solar advisor model software was renamed to the system advisor model software. The most of the researcher involved in the field of renewable energy field, the system advisor model helps to develop the implementing the energy field, renewable energy field. So the system advisor model using very useful for renewable energy side, renewable energy research side. Next, wind farmland. There are three different locations were selected in USA. The three different lands are North and Western Indiana for flat land, North and Western Montana for Kenya land, East and North Carolina for offshore land. This land to analyze the wind power forecasting of different land by using system advisor model software. So the wind forecasting parameters varying depending upon the geographical location. So the wind forecasting parameters are wind speed, wind direction, pressure, air temperature. These are the wind forecasting parameters. These forecasting parameters to upload the system advisor model software to generate the different location result. A different location result. This is the monthly AC energy production result. So the three different land monthly AC energy production results. This is Flatland monthly AC energy production result. This is monthly AC energy production for Kenya land. This is offshore land monthly AC energy production. So the monthly AC energy production for flatlands. So minimum of wind energy is produced for June, July, August. So 3 months for minimum wind energy is produced. Maximum wind energy is produced for November, December, and January. So 3 months for maximum wind energy is produced. Next, Kenya land. Kenya land minimum wind energy is produced for August month and maximum wind energy is produced for November, December, and January months. So 3 months for maximum wind energy produced. Next, offshore land. Maximum wind energy produced for December, January, February, March, and April. So 5 months for maximum wind energy produced. Minimum wind energy is produced for August month. So compare this three land. The maximum wind energy is more than month is maximum wind energy is produced for offshore land. Uh, so in all the three lands, offshore land for more month is maximum wind energy is produced. So one of the best land for implementing the new wind farm, that is offshore land, is one of the best land. Next, summary of the result. Summary of the result for three lands, flatland, Kenya land, and offshore land. Three land summary result. Um, annual AC energy is production for flatland 5.67083 into 10 power 8 kilowatt hour. Kenya land annual AC energy production 5.8366 into 10 power 8 kilowatts hour, and offshore land annual AC energy production is 6.99249 into 10 power 8 kilowatt hours. The maximum annual energy produced for offshore land and the minimum annual energy AC production is flat land. Compare the three lands. Next, capacity factor. Capacity factor choosing the uh, different level 0 to 100 percentage and depending upon the generator size. The capacity factor in flatland for 32.3677 percentage, and the Kenya land capacity factor is 33.313339 percentage, and offshore land capacity factor for 39.9115 percentage. The maximum capacity factor is offshore land and minimum capacity factor is 32.3677 percentage for flat land. Next, levelized power purchase agreement price real. Flatland levelized price for 3.43969 cents per kilowatt hour, and Kenya land for 3.4969 cents per kilowatt hour. Next, offshore land for 3.4. So all the land levelized price is same. Same. Next, levelized cost of energy real 3.55451 cents per kilowatt. This is the maximum levelized cost of energy for flat land, and minimum levelized cost of energy for offshore land 2.67128 cents per kilowatt hour. So the maximum annual energy is production for the land, offshore land. The offshore land result for maximum energy result for 6.99249 into 10 power 8 kilowatt hour per year. So the comparison of result, to compare the result, the offshore land one of the best land for implementing the renewable energy. So offshore land for monthly annual energy production for maximum more month maximum energy is produced. The level annual energy production for this maximum annual energy for 6.99249 10 power 8 kilowatts hour. So this comparison of all the result, the implementing the new wind farm, the offshore land is one of the best land. Next, the highest value offshore land for power generation is around 6.9923 in 10 power 8 kilowatt hour per year. Next, conclusion of the my paper. Uh, To find the simulation result from the system advisor model software, offshore land generate the most wind energy to produce the offshore land. So the greatest economic location to produce the wind energy is offshore land. Greatest economic location uh, for offshore land. The system advisor model helps to implement and developing the new wind farms. So the offshore land is one of the best land to implementing the new wind farm by helping the system advisor model software. Next, these are the reference for my paper. So all the paper my reference. Uh, Thank you. Thank you so much.